Good day, dear participants of the conference. To your attention is presented study on the topic Research and calculation of the levels of high harmonics of rotary electric machines in active adaptive networks. The quality of electrical energy significantly affects the reliability and efficiency of electrical networks and power equipment. One of the important indicators of the quality of electrical energy is the level of high harmonics, which causes non-sinusoidal modes of operation of electrical networks. Modern trends in the development of electrical networks, namely the introduction of active adaptive networks, introduce new aspects regarding the quality of electrical energy. The study of the nature of individual harmonics is of significant practical importance. This is confirmed by the study of, for example, third saturation of the magnetic circuit and toothed harmonics, which appear as a result of the unevenness of the air gap of rotation electrical machines. Therefore, the study of groove harmonics is relevant. The purpose of the study is to obtain scientific result regarding the nature of groove harmonics of rotation electrical machines and to establish the characteristics of their distribution in electrical networks. High harmonics of distribution electrical networks have a constructive or technological nature. Each harmonic component has one or more sources and defined propagation space. The amplitude value of the high harmonic and its flow paths are determined by the interaction of the inductive and capacitive elements of the electrical networks. The most unpleasant case is the case of resonance of higher current or voltage harmonics in electrical networks and large enterprises. Their manifestation in time determines the random or systematic nature of high harmonics. In the process of operation, electric rotary machines generate groove harmonics in the electrical network. The appearance of these harmonics is related to the magnetomotive force of the rotor winding. Their frequency can be determined by the expression 1. The amplitude value of these harmonics is determined by the design parameters of the electric machine and the network voltage. The significant downgrade of groove harmonics is caused by the dependence of these frequencies on the network frequency and slippage, which can lead to resonance phenomena. The energy level of the slot frequency induction harmonics characterize the magnetic losses in steel from the slot order magnetic field. Specific magnetic losses in steel are determined by the expression 2. In the general case, taking into account all terms of the Fourier series, for specific magnetic losses from the upper slot frequency in induction, obtain the expression 3. Thus, the specific magnetic losses from the upper groove harmonic of the induction depend on the value of relative electromagnetic asymmetry. The nature of this dependence is completely determined by the nature of the graph in figure 1. When determining the losses by the coefficient k, taking into account only the first two members of the harmonic series, the relative error of the calculation, with an electromagnetic asymmetry of up to 50%, does not exceed 2% and then it begins to increase. Figure 2. Calculation of the third term of the harmonic series significantly increase the accuracy of the calculation. The error in determining losses by the coefficient k does not exceed 2% with asymmetry up to 80% and increases to 8 plus 10% with an increase in electromagnetic asymmetry up to 90%. Figure 3. The study proposes a method for determining the energy level of higher harmonics, which can be estimated by the sum of the squares of electromotive force of groove harmonics, taken then each of the three phases of the starter winding is turned off sequentially during the operation of the electric motor. When the electric motor operates in the three-phase mode, taking into account the spatio-temporal distribution of the slot frequency induction for the slot harmonics of the first order induction, obtain the expression 5. The proposed technique allows determining the energy levels of higher harmonics not only taking into account the value of absolute and relative asymmetry, but also taking into account the direction in space of the plane of asymmetry in relation to the distribution of the starter windings. The dependence of the electromotive force of the grooving harmonic of individual phases and the sum of the squares of the amplitudes on the magnetic electromagnetic asymmetry was calculated on an electronic computer. Figure 4. The developed technique makes it possible to determine the levels of groove harmonic components in the phase windings of electric machines. These harmonics depending on the connection scheme of the asynchronous motor winding, start delta. The scheme and the load of the electrical network spread over the electrical network, creating current harmonics or voltage harmonics. All asymmetric emergency damage in the electrical network, disconnection of phases, short circuits of individual phases to each other and to the ground, can be displayed quite simple then forming nodal equations, taking into account the corresponding commutation in nodes and branch of a three-phase network. Moreover, the presence of several asymmetric damage does not lead to any complication in the algorithm for forming and solving nodal equations compared to the case of local damage. Therefore, mathematical models based on equations in phase coordinates are more flexible and universal, applicable for the analysis of non-symmetric modes of operation with both simple and complex asymmetry. It was established that the levels of groove harmonics are determined by the structure and modes of the electrical network, the geometry of the groove zones, of the air gap of electric machine and its magnetic properties. The last slide presents the conclusions of the study. Thank you for attention.